Let's talk about the steps that you have to do when you are testing a hypothesis. First, you need to determine in the problem which one is the claim. Which is the claim? The claim could be this hypothesis that the parameter is equal to the previous result, or this hypothesis the parameter is different to the previous result, or more specific, the parameter is bigger than the previous result or is smaller than the previous result. This could be the claim. Any of these could be the claim. Then after that, we need to determine which one is the null and which one is the alternative. Remember, the null states that there is no difference with respect to the previous study. Always have the equal. And the alternative could be any of these. Two-tailed test, right-tailed test, or left-tailed test. The next step will be, in the next step, we need to verify the requirements. And we need to write the significant level alpha or type 1 error, which is given in the problem. Then in the third step, we need to compute the test statistic. What is the test statistic? We need to transform all my evidence from my sample in one statistic that could be z-score or t-score. And the step number 4 could be the classical approach when we use critical values, two critical values for two-tailed test or one critical value when it's one tail. And the last step is conclusion. In my conclusion, I will reject or I will fail to reject the previous study. The previous study states that the parameter is equal to some value. Then in this step, in the step number 3, we need to compute my test statistic. The test statistic summarizes all my evidence taken from my sample, and this test statistic will tell me how far away is my evidence from the previous result, from the null hypothesis. If we assume that the parameter of the population is equal to the result that we obtained in the previous study, then we take a sample right now and we compute my sample's mean. Then the test statistic could be the z-score or could be this t-score, depending on those requirements. We need to verify those requirements to use z-score or t-score. Remember the definition of z-score. The z-score of one value is the number of standard deviation that this value is from the center or the mean. In our expectation, all samples mean follow a normal distribution with the center should be, in our example, 100. This is the mean of all samples mean, and the standard deviation of all samples mean is given by the standard deviation of the population divided by square root of my sample size. Then if I select this sample and suppose that this is the sample located in my distribution here, then the corresponding samples mean is this, then the z-score of this sample is this value minus the center, which is this value, divided by the standard deviation of this distribution. Then this score will tell me how far away is my evidence from the center. The t-score is very similar, but remember the t-score, we use instead the standard deviation of the population, we use the standard deviation of this sample. Sigma is the standard deviation of the population. Remember, when my sample size is bigger or equal than 30, the standard deviation of the population could be approached with the standard deviation of my sample. Then in the last step, in conclusion, we are going to compare my evidence condensed in the test statistic with the critical value. Then remember the critical value divide the rejection region from the do not rejection region. If my evidence falls in this region, we reject the null. If my evidence falls in this region, we do not reject the null. And that is my conclusion. The step number 4 could be done in two different ways. Using the classical approach, when we compute the critical values, we obtain the critical value and we are going to compare the test statistic with those critical values to reject or fail to reject the null. Or we can use p-value approach. Then what is a p-value? The p-value is a probability value associated with my evidence, with with my test statistic. If this is my expectation according to our example, previous study, the mean is 100, we assume that 100 is in the middle. Then if we get this value from my sample, then the p-value is the probability to get this value or one value more extreme in the direction of my alternative, assuming that this distribution is true. This is the center and this is the distribution for all samples means. Remember, the alternative hypothesis could be two-tail test. Then the direction will be this probability multiplied by 2. Then if my alternative hypothesis is right-tail test, then if this is my evidence, the mean of my sample, then the p-value of this sample, the probability to get the value or one value more extreme, in this case will be in the direction to the right because it's a right-tail test. The probability to get this value or one value more extreme in that direction. If our alternative hypothesis were less than, then this is a left-tail test. This is the case that when we suspect that the mean is smaller than the value obtained in the previous study. Then in this case we are expecting one value on the left. Suppose that my evidence is this, then this is my evidence. Then the p-value is the probability to get this value or one value more extreme in the direction, in this case to the left. The probability to get one value or one value more extreme. The p-value should be this area. And if we are doing a two-tail test, we suspect that the mean is different to the value obtained in the previous study, but we don't know if the mean could be greater or smaller. We state that it's different. Then in this case, we need two critical values. The equivalent procedure for this critical value will be a p-value with two-tail test. In this case, we need to multiply the extreme area of my evidence by 2. In this case, the evidence could fall on the left or on the right. In both cases, we find always the extreme area and multiply the extreme area by 2 when we are doing a two-tail test to obtain the p-value. The p-value tells me how far away is my evidence from the center of my expectation. For example, if we were doing a right-tail test and suppose that my evidence falls here, this is my evidence, then this p-value is very big. That is the p-value. The closer is my evidence from the center, then the p-value will be bigger and bigger and bigger. However, if my evidence falls far away from the center, for example here, this is my sample, this is my evidence, then the p-value is small. This extreme area is small. And the farther my evidence falls from the center, then the smaller will be this extreme area, which is the p-value. Then the criteria that we use to make a conclusion using p-value procedure is as follows. If the p-value is smaller than alpha, is because my evidence fall far away, then we reject the null. However, if the p-value is bigger than alpha, then we fail to reject the null, because if the p-value is bigger than alpha, that implies that my evidence fall close to the center of my expectation.